President, may we go ahead? Thank you. I'm Richard Portis, London Business School and CEPR, and I have a huge pleasure myself in introducing our lecturer this morning, Yuriy Gorodnichenko, who is the Quantedge Presidential Professor at the University of California, Berkeley. He's a research associate at NBER, a research fellow of CEPR, and a leader of CEPR's Ukrainian initiative. He has been key in bringing Ukraine reconstruction to the attention of the economics community. Now, what about the journals at the center of our professional lives? Yuriy is a co-editor of the AER. Previously, he was a co-editor of RCTs and the JME. He's a co-founder of Vox Ukraine. His research has been primarily about monetary policy and expectations and fiscal policy. Yuriy has co-authored several proposals, too, on the post-war reconstruction of Ukraine. His papers have appeared in all the top 5 journals, all 5 of them, as well as our own competitor journal, the GIA. Yuriy has received awards for his teaching and research, including a Sloan Research Fellowship, an NSF Career Award, and fellowship, very distinguished, fellowship of the Econometric Society. When Yuriy was a young economist, and I put that in quotation marks, it wasn't so long ago, REPEC ranked him as #1 in the world in terms of citations. He may no longer be quite so young, but he's still top, and we are very fortunate to have him as the Schumpeter lecturer this year in Bordeaux. Yuriy.
Thank you very much for this generous introduction. Thank you very much for having me. It's a great pleasure and honor to give this lecture. But before I continue with my slides, I also want to congratulate Julie and David for their well-deserved awards. It's a wonderful achievement. I'm very happy for you. Now, my talk, if I can have my slides on, is going to be about expectations, why they matter in economics and specifically in macroeconomics, why we care about this, what we have learned over the last 10 or so years in this field, and what kind of progress we can expect to happen going forward. And just to manage your expectations, why we care about inflation expectations or expectations in general. When you look at almost any macroeconomic relationship that we have in our models, all of them are going to have some type of intertemporal dimension. What we want to do today is going to depend on what we think is going to happen to us tomorrow, in a week, in a month, in a year, sometimes in 10 years. And so these expectations are going to show up in almost every decision we're going to make. For example, it's going to affect our consumption decisions. If you look at firms, it's going to affect their investment decisions, how we price goods, how we set wages, how we hire and fire people. It's extremely important for policy making. So almost everything we do in macroeconomics, or economics in general, is going to be a function of expectations. Now, just as an example of why we care about expectations in the policy world, this is a quote from Jerome Powell, and to my great surprise, he had exactly the same sentence in multiple speeches, and he had more sentences like this going forward. And before it was maybe a mundane statement that we care about inflation expectations, inflation, but now it may be interpreted as an act of courage when you care about inflation and not something else going on in the economy, especially in the US. Now, one challenge for this literature, for this line of work, is that obviously expectations are highly endogenous. And we know in macroeconomics, identification challenges are particularly acute because, unfortunately, for the science of macroeconomics, we can't run experiments. But for the public, it's probably a great outcome. We don't experiment on millions of people. But nonetheless, if you want to address a big macroeconomic question, you have to rely on all sorts of creative techniques to have some type of causal statement about how, say, monetary policy affects the economy. What is the size of the fiscal multiplier, things like this. It's even more difficult to answer questions how expectations are actually affecting the economy because we don't have good measures of expectations, or at least all of them. We also have endogeneity concerns, identification issues. Lots and lots of things are kind of delaying our progress in this arena. Now, having said this, macroeconomists are very creative in addressing these challenges. We are not spoiled by random variation or anything like this. So we try to come up with something which is going to be close enough, but maybe an imperfect solution to answer these important questions. And some strategies are very intuitive and very appealing in many ways. For example, if you don't observe expectations, maybe it's okay. You can make assumptions about how people form expectations, how they act on expectations. Then you put these assumptions in a model, you simulate a model, you compare simulated model series with actual series, and if the distance between the two is close enough, you can claim success, and you can say, well, this is a way for me to understand how expectations work because I can rationalize what I see in the data with my simple model. Now, obviously, you have to make an assumption here, and if you make alternative assumptions, you can have very different results. So there is a lot of sensitivity in this line of work. An alternative approach is to make it a little bit less structural, potentially, make it less systems-based approach, focused on specific relationships, such as consumption-Euler equation. Again, make a few assumptions about the nature of the error term that people have in their forecasts, estimate this single equation relationships, and again, learn something about how people form expectations and how they act on expectations. Again, it's a very intuitive, very appealing approach. Also some limitations. You learn about one relationship, you don't know much about other relationships. Another approach, which is in some ways is more challenging but potentially more informative, is to measure expectations directly. So instead of making assumptions about how people form expectations, for example, without relying on full information or rational expectations, you just say, let's ask people what they think is going to happen with inflation, with GDP, and you can ask questions for professional forecasters, for consumers, for managers, for members of FOMC, ECB member, governing board, whoever is your target audience, your favorite group of people, you can ask them about their beliefs and see how these beliefs are going to be correlated with their actions. Now, obviously, it's very informative because we see what is the sign of this correlation, what is the intensity of this correlation, but you obviously cannot make many causal statements about how expectations are actually affecting the decisions. Now, a new line of work that has emerged over the last 10 years is to basically learn more from microeconomists and start to use randomized controlled trials to answer macro questions. Right? So in principle, what you can do, you can have a control group and a treatment group, see how people change their beliefs when they're treated with pieces of information, and then see how they act on these updated beliefs, if they're going to react to those beliefs. Now, I'm not sure how many people have been running RCTs. I'm sure our micro colleagues have done this all the time, but in macro arena, this is very unusual. So I just want to make sure everybody is on the same page and understands the basic structure of this approach. Now, in some ways, it's a gold standard in science because we can really make important causal statements, but it has a little bit of, somewhat unusual structure if you think about this. The first step of this approach is very simple and intuitive. You just elicit expectations that people have about inflation, GDP, unemployment, whatever variable you care about. And you can ask questions that are going to inform you about the first moment beliefs that these people have, for example, an average forecast, or uncertainty that people have in this forecast, that will be the second moment. Or maybe you can talk about other moments of inflation expectations. So in fact, expectations of other agents that people have, right? So you think, I think, you think, I think kind of expectations. You can also ask people to report their planned decisions. Do they want to buy a car, a house, or anything like this? And this is going to be very useful because it's going to give us a benchmark for comparison going forward. Now, once you're done with this stage, you're going to flip a coin, and some people are going to control group, and some people are going to the treatment group. And these two groups are going to be identical in all respects by one. They're going to have the same age distribution, they're going to have the same political distribution, they're going to have the same education, gender, everything is going to be the same. The only difference is going to be that the people in the information group are going to receive a brief sentence, a piece of information that you want to communicate to those people. It may be some basic fact about inflation, unemployment, or GDP. And then you want to see how people react to that information. You ask them again to report their beliefs about the variable you care. This is going to be our posteriors. At this stage, if you see any difference between these two groups, at this stage, if you see any difference between these two groups, you know, the only reason why there may be a systematic difference between these two groups is that these people here received the information and these people here did not, right? Because otherwise, these groups are identical. As I told you, they're going to have the same age distribution, income distribution, everything is going to be the same. Now, you can continue this experiment and you could say, okay, suppose I can successfully change your beliefs. There is a systematic difference between these two groups. Are we going to see any differences in behavior that these people have, right? So you ask them again, many months later, did you buy a car? Did you buy a house? Did you change your portfolio locations? There are many, many important decisions that we care about in macroeconomics and economics in general. And again, if you see any systematic difference at this stage, we know it has to come from systematic differences in this stage. And as I told you in the RCT, in this randomized control trial, we can perfectly control the flow of information. And so we know it has to come from this stage. There is no other explanation. This is the power of randomized control trials, that you can have very sharp causal statements about actions, beliefs, and shed new light on how people collect and process information, how they act on expectations, and so on. Let me give you an example of how this works in practice. And this is based on my recent paper with Oliko Obion and Michael Weber. We did this in a quiet time. This was in 2018 when inflation was very low, very stable, a very boring subject. Most people didn't care about inflation. In fact, we were told that you are wasting your time on a subject like this. Now nobody is saying this, so we made a lot of progress there. What we did, we used a huge sample of households in the US, roughly 20,000 people who participated in this experiment. We asked people to report their inflation expectations. We were interested in this particular thing. We also asked them to report their beliefs, and then we gave them basic information treatments. This is some of them. One was to report the most recent inflation numbers. Again, this was the time when inflation was very close to 2%. I can't remember the exact number, but it was something like 1.99 or 1.95. Only macroeconomists would care about the small differences from the inflation target. Well, also, another group was told about the inflation target of the Fed, which was 2%. Yet another group was told about the inflation forecast from the Fed. At that time, it was very convenient because each of this treatment was basically conveying inflation is going to be, and supposed to be 2%. So there was no variation in the intensity of the numbers that we provide to these people. So it's great. And then we see how people change their beliefs in response to these treatments. Now, how this works? Okay, so what we want to do is to compare priors and posteriors of inflation expectations. Right? So this is a prior expected inflation. This is posterior expected inflation. We have to ask posteriors, elicit posteriors with a slightly different survey question because people in the control group may be suspecting something if we ask the same question twice. So we have to be a little bit more creative here. But qualitatively, our theory is telling us that when we do this questions very close to each other, maybe 5 minutes of survey time, in this narrow window, people should not have any systematic reason to revise their beliefs. So their posterior should be very close to their priors. Basically, this relationship here, this bin scatter, should be very close to the 45-degree line. We don't get this exactly 45-degree line, and this is probably coming from the fact that we are asking questions slightly differently at the posterior stage. But qualitatively, it is very close to 1. Now, this is the control group. What happens if you tell people that inflation target of the Fed is 2%, or if past inflation is going to be, or if inflation is going to be 2%, or if inflation was 2%. Qualitatively, you get something like this. Suppose you start with somebody who initially thought inflation is going to be 10%. Okay, so these people, there are lots of people like this in the US. I'm sure it's the same in the Euro area. You start with these people and you tell them, well, the inflation target of the Fed is going to be 2%. Now, if these people are rational, they have priors, 10%, they get the signal, it's going to be something like 2%. Your posterior should be somewhere between these two numbers. How much you move in this direction depends on the precision and credibility of the signal. If the signal is very precise, very credible, you should jump all the way from here to here. Now, what's important here is that we create exogenous variation in beliefs, right? So people here continue to believe inflation is going to be 10%. Here, these people are revising their beliefs for exogenous reasons. We control this because we provided information to those people towards the provided signal. Now here, another group of people who initially thought inflation is going to be 6%, you tell them the inflation target is 2%. Again, these people are going to systematically revise their beliefs towards the provided signal. On this end, people who initially thought inflation is going to be 0, you tell them very likely it's going to be 2%, you're going to revise their expectations up. And obviously when inflation is 2 and they expect it to, they don't have any reason to revise their beliefs. Right? So this is where we have an intersection. So what you should see here is, one, we provide people with publicly available information. Everybody should know that the inflation target of the Fed is 2%. Nobody should be surprised to learn this information, and yet people appear to revise their beliefs massively in response to this publicly available information. So it's telling us there is some type of information friction. We don't have full information, rational expectations, which is the backbone of many, many macroeconomic models. That's number one. Number two, we see that the size of this revision is going to tell us something about how credible or novel information is. If you tell people something they already know, they should not be changing their beliefs. Basically, it means these lines here should be very close to the black line. If you see a big revision towards the provided signal, it's telling you that this information that you tell to people is going to be very novel, very credible, very useful for them. Okay? And finally, as I said, the fact that we can control who is going to receive information and who is not going to receive information is creating for us exogenous variation in belief, something we couldn't do before with just observational data, because we don't know how people get information, how they process information, how they come up with their beliefs, and certainly don't know how they act on those beliefs. Now, there is a simple way to connect this very simple bin scatter plot to basic economic theory and also econometrics, right? So if we assume that people are, somewhat at least rational, they should be Bayesian updaters. Their posteriors should be a weighted average of their priors, for example, about inflation, and the signal we give to them. And the weight on the signal, this G, is nothing else but the gain of the Kalman filter. If the signal is very strong, very powerful, this means G should be very close to 1. If the signal is not novel, if it's not powerful, it should be very close to 0. Now, when you look at this equation, it then follows very naturally that there is a simple regression specification going forward for this, where you rest posteriors on priors. This is a dummy variable equal to 1 if you're in the treatment group, and the interaction of the prior in the treatment dummy. And then you have an error term, maybe measurement error or something like that. Now, so what this means then, if you run this for control group, we know that this alpha should be equal to 0, beta should be equal to 1. If you're going to run this effectively on the treatment group, you're going to have a combination here for the intercept alpha plus delta. This delta is going to be the level effect, basically. What is the average distance between the signal you provide to people and their initial beliefs? And gamma is going to tell us something very directly about the gain of the Kalman filter. So it's a very simple specification. You can estimate this with OLS because through randomization we know this is exogenous, this is exogenous, this is certainly not correlated with the error term in any shape and form. All right, so kind of very basic econometrics here. The best possible regression, OLS, right? Very intuitive. You can visualize this easily with a bin scatter plot like this. Now, once you do this, then the next stage is this. You say, okay, I can change beliefs. I can create exogenous variation of what people think about inflation. But, maybe this is just happening in the heads of these people and they don't act on this information. So there is really no genuine effect on their lives in terms of consumption, portfolio allocations, employment choices, all sorts of things like this. How do we know that this change in beliefs actually changes actions? Now, one simple way to answer this question is to basically use the insights we just developed and run a two-stage least squares regression, or instrumental variable regression, where you have your variable you care about as an outcome, for example, consumer spending. You regress it on posteriors of inflation, priors of inflation, and a bunch of controls here. You don't have controls here. This is just a way for us to reduce the size of the error and so make more precise estimates here. Now, we don't have really an interpretation of this coefficient C1 because we don't know where priors are coming from. They're clearly endogenous. But what we can do is to focus on the exogenous component of variation here, and we know how to estimate this exogenous component, right? So this is the equation we can estimate. This is our first stage, and it is very similar to what I showed you here, right? So this is telling us how you can create exogenous variation in beliefs. We're going to use this variation, and this B is going to have a causal interpretation, basically saying holding everything else constant, you raise inflation expectations by 1 percentage point. What is going to be the causal effect of this on, say, consumer spending? Now, does it work? Okay, so that's a big moment. We spent a lot of money on this experiment. It was a lot of waiting. And then 3 months later, we asked people, how much you spend in terms of non-durables. And first of all, we have a very strong first stage, so we'll never have problems with weak IVs or anything like this. When you look at the estimates, you find that you raise inflation expectations by 1 percentage point, and you're going to have an increase in non-durable spending by roughly 1 percentage point. So this is telling us that in our standard models, expectations don't have a separate life. Everything has to be model consistent. There is no exogenous variation in beliefs. So that's why it's so hard to establish the effect of expectations on anything that people do in their lives. Here we create exogenous variation in beliefs, and we see they're going to respond to this change in beliefs strongly. And from this coefficient, we can learn a lot about, for example, intertemporal elasticity of substitution or other structural parameters. So there is something useful there. Now, this is just one application, and this literature has been really exploding. You see applications to macroeconomic uncertainty, to international macroeconomics, to housing, to financial markets. There are lots and lots of things you can do here, and obviously this is just scratching the surface. The main appeal of this approach is it's so straightforward. It's really hard to then have a debate about where the expectations or anything like this are going to affect choices of people, agents, financial traders, and so on. Now, obviously, you have to think about lots and lots of issues that may come up with this approach when you implement this. One is how you interpret these numbers, okay? And to illustrate you some of the issues here, this is from a very nice paper by Van Vernen where he derives under general conditions. You don't have to rely on, for example, full information rational expectations, so just some expectations coming from somewhere. He says, well, if you do a little bit of algebra, actually a lot of algebra, but in the end, it's going to be a very simple equation saying that inflation today should be a function of expected inflation and this other term here, which does not depend on expectations. So it may be productivity, market concentration, things like this. And so in principle, what we want to do is to have an exogenous variation here holding this object constant, and this is going to tell us what's the pass-through from expected inflation into actual inflation, a big topic today, at least in the US. You have massive increase in inflation expectations. We want to know how much this is going to translate into higher inflation going forward. Now, one challenge here is when you change inflation expectations, you obviously will change this object here directly, but then you can have an indirect effect, where by changing this object here, you're going to change this object here as well. So think about this as you change inflation expectations. People are also going to change their expectations about unemployment, GDP, or some other variable, something like that. And then what you see in your regression results is this number, and this is going to be obviously a combination of these two different forces. You're going to see what we call the total effect. And sometimes this is all you need to know. For example, if you're Christine Lagarde or Jay Powell, you just want to change inflation by a certain number, and you don't care that much about how this is achieved exactly. But obviously, in terms of macroeconomics, in terms of science, academia, we really want to understand the channels. Is this mostly coming from this effect or from this effect? And then it becomes very difficult to address just with this very basic framework. You have to be a little bit more sophisticated when you do this. But in a nutshell, what you want to do is to do information treatments which are going to have differential movements for this object here and for this object here. If you can do this, then you can identify separately the direct and indirect effects. So you just need to be a little bit more creative here. And to show you how much creativity we have, I'm going to rely on this recent paper with Dimitris Georgarakos, Jeff Kenny, and Oli Kuobion, where we're interested in the effects of changes in the behavior of people when they become more uncertain about inflation. It's kind of a perfect scenario for the US now, where uncertainty about inflation is off the charts. Now, it's a great question, very important question, but we have a problem here. And the problem is that when you look at inflation uncertainty, it is very highly correlated with the first moment of inflation expectations. So if you have high inflation expectations, you're also going to have higher uncertainty about inflation. And you can see from this bin scatter plot, this relationship is very strong. So what we want to do is to hold somehow the first moment constant and change the second moment, right? So that's what we want to do. That's the challenge for us. And so what we want to do then is to come up with treatments that are going to generally move the first moment, but maybe less so the second moment, and then come up with an information treatment that is going to move the second moment, but not necessarily the first moment. And as an example of what we did this, I'll describe the treatments for you in a moment, but what is great in this study is that we rely on this wonderful data from Consumer Expectations Survey run by the ECB. It's a wonderful survey. I keep praising this. I thank Jeff and Dimitris for creating this survey and keeping it alive. It's now a huge resource for anybody interested in expectations. Lots and lots of observations, a great coverage of countries. It's a monthly panel, so you can answer lots and lots of questions relevant for macroeconomics. One part which I particularly like about the survey is that even though this is run by the ECB is open to using this survey to answer kind of big science questions. How people form expectations. We want to allow people to run RCTs. That's very unusual. Most central banks don't allow you to even approach the surveys in any way. What is also great about the survey is that it's not only about expectations, you also have lots and lots of questions about the actual behavior of people. So you can track these people over time, and you can see if this information treatments are going to affect their spending, investment, labor market decisions. So lots of useful things here. Now, treatments. So, one constraint here, it's not constraint for Donald Trump, but it is constraint for us. We can tell people only true facts, genuinely correct information. So we can tell them in the first treatment that the average inflation forecast was such and such number. It's available from the ECB website. So we don't make up any information, only kind of genuinely correct information. This is supposed to move mostly the first moment, and maybe to some extent the second moment, but mostly the first moment of inflation expectations. Then the second treatment, that's another group of people. We're going to tell them something about uncertainty that these professional forecasters have. And this treatment is supposed to move mostly uncertainty about inflation outlook that households should have, and not necessarily move the first moment. But in principle, you can have movements in the both moments. And the third treatment is going to be a combination of the first two, just to see if there is any interaction effect. I don't have time to describe this in great detail, but in a nutshell, when you look at this information treatments, you can see that you can successfully move inflation expectations, first moment, inflation expectations, second moment. And these movements are not going to be perfectly collinear, which allows us to identify separately the effects of the first moment and the second moment. How do we do this exactly? Again, this is going to be a very simple instrumental variable regression, where you have an outcome variable you care about, maybe consumption, portfolio choice, anything. Then you regress it on posteriors, first moment, second moment, priors, and some controls here. You can't interpret really these coefficients here. You can't really interpret anything here. But if you instrument these variables here with treatment dummies and interactions of treatment dummies with interactions, this is going to give us sort of estimates of exogenous variation in these posterior beliefs, and then these coefficients, alpha 1 and beta 1, are going to have a causal interpretation. Now, as an example, we do these treatments, we successfully change the beliefs that these people have. Now, 1 month later, we want to see if this is going to affect their probability of buying a durable good, a home, a house, an electronics, or a holiday package. Again, we have very strong first stage. You can see it from this stage. But when you look at the estimates, kind of the most important part, you see that there is a big effect of inflation uncertainty on the probability of buying a durable good. So this is basically saying if you double uncertainty, which is roughly what we have with Trump, lower bound, right? So we more than double. We see that the probability of buying a house in a given month is reduced by 2.5 percentage points. It's a very big effect. But it makes a lot of sense from an economic standpoint, because if you have so much uncertainty, the bands of inaction are going to be very wide, and you are much less likely to buy this durable good. Now, when you look at the first moment, you see generally positive coefficients, and this is consistent with intertemporal substitution. If you think inflation is going to be high, you should understand that the real rate is low. It's a great time to buy a durable good. Now, here the effects are somewhat smaller, less precise estimates, but generally all positive. Now, why is this important for us? Well, this is what happens when you can successfully tease out the first moment and the second moment. But if you don't do this and instead estimate the total effect of just inflation expectations, the first moment, you will generally find a very negative coefficient here. This will be the total effect, which is a combination of this and this. Now, in a nutshell, this is saying that, this experiment here is saying to us that if you are, again, Christine Lagarde or Jay Powell, and you want to raise inflation expectations in the hopes that this is going to stimulate the economy, this approach would backfire, because instead of increasing purchases of durable goods, you will reduce the probability of buying durable goods. Right? And again, the intuition here is that high inflation expectations are positively correlated with inflation uncertainty. This channel is much more important than this channel. Uncertainty is more important than intertemporal substitution, and the net effect is going to be negative. Now, what happens if you don't have instrumental variable regressions, if you just rely on correlations? In general, you can't see anything systematic in the data. This is, again, to underscore the challenges, identification challenges we have in this arena, and the importance of using RCTs to identify causal effects. What is the persistence of this effect? It's kind of remarkable that we have 10 minutes of these people's time, and you change their lives, not forever, but only for 4 months, right? You can see that these effects are going to persist for about 4 months. They're less likely to buy a house, less likely to buy a durable good. It's remarkable that in this 10-minute exercise, we can have such a dramatic effect. And just again, to give you a perspective, when we think about quantitative easing, large-scale asset purchases, you have massive programs that have some effect, obviously, on purchases of durable goods. But this is saying that communication strategies can be equally powerful, if not more powerful. So if somehow you can penetrate through this wall of inattention that people typically have towards monetary policy, you can change their beliefs in very significant ways. So one more thing, which before I finish on this one. I emphasized a lot about consumption responses. It's just one of many margins that may be affected by expectations, obviously. And one great thing, as I said before, of the CCB survey is that it has many, many, many more actual choices, questions about actual choices made by households. For example, there is a question, you have financial savings, how do you allocate it across different asset classes? And we can see 2 months after the treatment, what was their choice. And in a nutshell, what we see is that when you make people more uncertain about inflation, they are more likely to invest their resources in something which is very liquid. And again, it makes sense, because if you're uncertain, you need, in emergencies, access to your assets very quickly. This is why you're going to put your money in a bank account, effectively. However, if you have high inflation expectations, obviously you don't earn any interest on this. It's very costly to have high inflation. You are less likely to put your resources into these liquid accounts. Now, so one point I want to emphasize was this, that this very basic exercise, even without necessarily structural interpretation, can already teach us a lot about what policymakers should be doing. For example, the idea that you should be raising inflation expectations to stimulate aggregate demand is not necessarily going to deliver the results you expect. It's going to be more complicated. And in the current environment where people have a lot of uncertainty about inflation and many other macroeconomic variables, you can really improve the economy by providing more guidance about where the economy is going. I know it's very hard at this stage in these conditions, but anything you can say to narrow the ranges of what can happen is going to be really helpful, I can tell you, as a citizen in the US. Now, there are many other things that can go wrong, and we have some ideas how we can address this. For example, how do we know that information treatment is working? And we have some positives and negatives here. For example, inspired by our success in the Nielsen survey and also another survey done with Dimitris and Martin van Rooij in the Netherlands, we wanted to do a similar experiment in Uruguay, this time with firms. We do our RCT, we look at the estimates of the treatment effects, the change in the slope that I showed you before. This is going to be on this axis. And generally, you should see that these estimates are going to be very close to zero. So we tell people about past inflation, these managers in Uruguay, and they are not really responding to this information. We did this again. We thought we made a mistake here. We have even worse response. And so we got stuck here for about 2 years. We didn't know what to do with this project because, a non-result is very difficult to publish in economics. I can tell you this as an editor. And so we sit on these results for a long time. And then, luckily for us as scientists, we had a surge in inflation in the US, and we realized that this is something more important than we thought initially. How did we learn this? Well, we did this experiments with information treatments in the US. This is what I showed to you before. This is the change in the slope in Nielsen in 2018, 2019. You see these treatment effects are very large, right? So you have massive revisions in beliefs. When inflation took off, we said, why don't we do another experiment and see if people are going to respond differently to these information treatments? And so we kept doing these experiments over time. And we can see here that these treatment effects got a lot smaller. Why is that? Well, because if inflation is high, the cost of a mistake in your beliefs about inflation is going to be obviously more costly, and you should allocate more attention to tracking this macroeconomic variable. Now, in a few years, we'll do an experiment probably somewhere here to see if we come back to this scenario here. It doesn't seem very likely, but hopefully we're going to come back to where we were initially. But this relationship inspired us to the idea that, well, maybe attention is a state-dependent variable, right? So the fact that people were so largely unaware about inflation or the Fed or anything like this, and they became much more knowledgeable about this subject in an environment where inflation is high. If this is kind of a general pattern, we should see it in different countries in different times. And this is what we did here. This is a joint paper with Michael Weber. It's 13 co-authors. It's probably a full page of co-authors in Econometrica. Probably we set the record there. What you see here is that on the horizontal axis, you have the level of inflation at the time of this experiment. This is the treatment effect. If you get to -1, it means people are really not knowing much about monetary policy and inflation. If the effect is 0, it means you tell people about past inflation, inflation targets, things like this. They are not responding. It's telling you they actually know this information. And you can clearly see a positive relationship here. And Uruguay was somewhere here because on average this country has about 10% inflation. People pay attention to this subject, and so they are not sensitive to the provision of information. So this is to tell you that when you do this information treatments, you have to tell people something which is reasonably important, but something that people don't know 100%. If they know this subject, it's very unlikely that information provision is going to change their beliefs, and therefore you're unlikely to find any kind of treatment effect. So people learned a lot about this subject during this surge of inflation, and I guess one way to see this is to look at the distribution of responses when you ask people, what do you think is the inflation target of the Fed? When we did this in 2018, remember this is the time when nobody cared about inflation, lots of people thought that the target of the Fed is something like 20%, or they just said, I don't know. Now, it was clearly obvious at that point that most people don't know what the Fed is, what monetary policy is, so it was sad for us. But when you ask the same question in the second quarter, this was done just after the Liberation Day. Maybe it was confounded, but unfortunately for us, we couldn't time the survey differently. But in any case, in 2025, after the surge of inflation, almost 40% knew that the inflation target of the Fed is going to be 2%. So people learned, okay? So they know a lot more about the Fed. Again, this is reflecting that attention is rising with the level of inflation. And we thought so to say, a useful lesson to the general public. They now know the inflation target of the Fed, but obviously it was a very costly lesson. We should not do it like that. We should communicate this information through other means. What else? Measurement of outcomes. Okay, so here an ideal scenario would be you do your information treatment and you don't bother these people ever again, right? So you collect information about their choices through some natural process, right? So for example, you look at their bank statements or some other administrative data, something that occurs naturally. We don't have this very often. Most of the time we're going to rely on surveys because we can merge surveys to administrative data. And so it is important to verify that self-reported measures of consumption or other choices that people make actually is consistent with the genuine behavior that these people have. And fortunately for us in Nielsen, we have this measure. There is a home scan panel, right? So people, when they make their purchases, they have to scan it. And Nielsen company will know how many tomatoes you buy, how many items you buy, and you can add up this, and you can know how much people spend on food and other non-durables. This bin scatter plot is telling you that there is a very high correlation between scanner data, kind of administrative data, and the survey data. So we can trust surveys when we ask people about their actual choices. This is another way to establish this fact. You look at the distribution of purchases. In the scanner data, this is the red line, and the black line is the survey. Generally these distributions are very similar, but obviously we have some differences. For example, we have the slumps here, here, here. This is reflecting the fact that when surveys are done, people are going to round up numbers because they can't remember the exact amounts they spend on food. But obviously it's not a constraint for administrative data. Now, how much difference does it make in practice in the end? What we can do, we can look at the sort of treatment effects, causal effects of inflation expectations in the scanner data, which is high quality, and survey data, which is high quality but maybe not as high. With the scanner data, I showed you this number before, very strong estimates, very precise estimates. We do this with scanner, and you have generally less precise estimates. Why? Well, part of all of this is that you have fewer observations. Just through sample attrition, you have fewer observations. With naturally occurring data, it's much less likely that these people are going to drop out. And obviously, you have better measurement of consumption in this source than in this source. But having said this, this is still very similar estimates. It just tells you that you need to have more bigger sample sizes when you do this kind of analysis with survey data. Alternatives. Okay, so I spend a lot of time advertising RCTs as a solution to many macroeconomic problems. It's not the only answer. There are many other ways you can address these important questions. And one very popular approach, increasingly popular approach, is to rely on hypothetical questions. You ask people, suppose you have this in this situation, how would this change your behavior? Would you spend more? Would you look for another job? This kind of things. And you can be very creative in thinking about these scenarios. Ideally in economics, we would say, suppose something happens, holding everything else constant. What would you do? Okay. Now, it's very hard for people to expect to understand, that, holding everything else constant. But, with this caveat, I think it's a very useful approach. How do we know this is working or not? Well, one thing we can do is to have hypothetical questions, and this is going back to our joint work with Dimitris, Jeff, and Oli. You can have RCT and hypothetical questions at the same time, and you want to see if there is consistency. These are some of the margins that you can contemplate in hypotheticals in RCTs. Are you shopping more intensively? Are you buying gold? Are you going to look for a new job? You can have many more scenarios when you analyze this. And then you compare hypothetical answers with what you see in their RCTs. And for margins that we can match to RCTs, we see a lot of consistency. Obviously, we can't match magnitudes because the units are going to be very different. But qualitatively, this is going to be very much consistent, which means this kind of approach has a lot of promise. Why is this so attractive? Well, most important margin here is that it's much less costly. You don't have to have a follow-up. You can work with smaller samples. There are many, many reasons why this is very attractive. It's also sort of unusual in the sense that it's very easy to study things which are hard to answer with RCTs. For example, if you're interested in nonlinearities or symmetric effects, you have to work with giant samples. With hypothetical questions, you don't have to do it. It can be very, very small samples, and you can precisely estimate this nonlinearities and asymmetric effects. So it is a very attractive approach, but obviously before we actively engage in this, even more actively engage in this, we need to establish that there is a high consistency between what people say in hypotheticals and what they do in real life. Now, to conclude, I'm sure many people in this room struggle with identification questions. It's #1 concern from referees, from editors. How do we know that what you find makes sense? How do we know it's a causal relationship? And in the context of expectations, this identification challenges are particularly difficult, right? Because everything is endogenous. We don't know what people know. We don't know how they collect and process information. And we don't know how they use this information for their decision making. Now, what I hopefully convince you that RCTs is a way to address this identification challenge, and it can help us answer some of very important questions in macroeconomics, and we can have, if not 100% causal statements about everything, we can certainly have sharper statements, causal statements about how the economy is working, at least at the micro level. What is also novel, I think, in this approach is that when you do this RCTs, you realize that you can rely on data from BLS, not because it's not credible, it's just, they don't participate in RCTs. Maybe we'll be concerned about the quality of BLS data going forward. But what's important here is that if you have a data source provided by the government, that data was collected with a particular objective in mind. They didn't want to test your specific hypothesis. With this RCT business, when you run your own service, you control every element of this. And so you can tailor questions specifically to your hypothesis. You can have much sharper answers. You don't have to make simplifying assumptions, all sorts of shortcuts. You can be very precise. You can create your own data. And I think this is a very novel element here. As I said, this has been already applied to many areas, but I think there is a much bigger scope of applications. It may be financial variables, it may be exchange rate variables, anything really is possible here. Now, having said this, obviously RCTs are not going to be a solution to every problem in macroeconomics. It's unlikely to address, all big questions we have out there. The challenges are, obvious here. You have to go from a micro-level study, which typically identifies a partial equilibrium, to general equilibrium. But the idea is that if you build strong foundations, it kind of sets up you to correctly design your models to understand general equilibrium effects. Think about this as, a wall of knowledge collected from, stones, this, experiments, RCTs. You get the stones, you put them in the wall, you keep building this wall. Sometimes the stones are going to fall off because it was their own experiment, there was a mistake, but you kind of keep building this wall, and at some point you're going to be in a position where you can reach and answer a big macroeconomic question. Now, if you want to know more about the next steps in this line of work, or in general, more details about what I described to you, I want to use this lecture as an opportunity to advertise a book by Oli Koabion and myself, which is going to come out later this year. Obviously, I'm not unbiased about this book. I love it a lot. But one thing I like particularly about this book is that its cover has the colors of the Ukrainian flag. Thank you. And I will be happy to take your questions.
So, generally IVs capture some kind of local average treatment effect. If you run an IV that changes people's expectations, it can only change the expectations of people who were relatively uninformed. Mm-hmm. And you might think that the most uninformed agents in the economy are also those with relatively low spending power. In some sense, is the impact that you're capturing sort of an impact on relatively uninformed but also relatively uninfluential economic agents? And how would you attempt to tease that out?
Yeah, so thank you for this question. There is this idea that captains of the industry, the government officials are much more informed about the state of the economy, and so they're not going to make crazy beliefs about the state of the economy, inflation expectations, and so on. There is some evidence consistent with this view, but certainly we have some prominent counterexamples. My favorite counterexample is when Elon Musk was given an interview in 2021, and somebody asked him about inflation, and he said there is a lot of deflation in the economy. People don't understand it. I don't know what he was thinking about in that particular instance, but it's clear that not everybody is informed about inflation, even at the top echelons. I agree with your general idea that you can change beliefs of people who are less informed. Right, and to some extent, the economics here is very clear. People who have stronger incentives to pay attention to inflation, they will be more informed about inflation, and so these randomized control trials are going to be less effective. And as a result, the mapping from expectations to their actual choices is going to be attenuated. So, at some level, this is telling us that what we estimate is probably a lower bound. Right. If somehow you inform people who should care about this stuff, and this is genuinely new information to them, we should see stronger changes in the behavior. So I agree with that. On the other hand, if you are Jay Powell or Christine Lagarde, when you communicate with the general public, you always have a mix of people. Somebody who is going to be more informed, somebody who is going to be less informed. And you hope that with your communication, you're kind of moving everybody on average. So you kind of try to tell some messages to people in details and change their beliefs about unemployment, inflation, GDP growth, and so on. So at some level, the value of what we estimate may be somewhat smaller because we can give you just a lower bound. But at some level, if you're focused on practical issues, what we do is effectively policy communication. When somebody is knocking on your door and says, Jerome Powell or Christine Lagarde has a message for you, inflation target is 2%, and then we see what those people do next with this information.
Thank you. Great presentation. So my question is about the first paper you presented. So inflation can be personal. People's inflation experiences depend on the basket that they consume. Mm-hmm. And I would assume that this shapes their consumption decisions more than the official inflation. So in your surveys, do you also observe that when you provide them with information, with official information, inflation, does this also adjust their expectation about personal inflation path?
It's a terrific question. Ideally, we want to have in our information treatments information that is going to be personalized, right? So something which is specific to the respondent. I wish we knew so much about these people ex ante to tailor something for them specifically. But occasionally it's possible. If you have a panel of households, you track them over time, you have a lot of information about their background, their lifestyles and so on, you can have information which is specific to this household. And in another study, also with Dimitris Georgarakos, Oli Coabion, and Martin Van Rooij, we will look at how information treatments about your income positions in the income distribution affect your consumption choices. So the idea would be if you learn that your neighbor's making more money than yourself, what would you do with this information? Are you going to consume more, trying to catch up? Or are you going to work more to earn more income to catch up? In that particular instance, we had to know a lot about these households to provide them personalized treatments. When we tell them, well, you're in this percentile and you're in that percentile relative to the income distribution of people who are similar to you. And ideally, this is what we want to do. But from a macroeconomic perspective, again, if you're Jerome Powell or if you're Christine Lagarde, you're talking to the general population. So probably you should communicate macro facts to those people. There's a question there.
My name is Nobi Hanaki from University of Osaka. Thank you very much for wonderful presentation. You mentioned so much about RCT and information intervention, But if you are trying to test like expectation formation models or like a link between partial equilibrium to general equilibrium in some model consistent way, then maybe the way forward can be to use better use of laboratory experiment, which have a lot of knowledge about. How do you think the use of laboratory experiment in the application for the macroeconomics?
It's a great question. It's one of the things we discuss in the book. Ideally, you want to have a combination of surveys done on the general population and something similar done in a lab. Then it's much easier to understand, general equilibrium effects, or you have more control over subjects in a lab. One example of what you can do in this context, we wanted to see how informing people about past inflation experiences can create sort of a fake memory. It's not a fake memory, kind of Inception, right? If you've seen this movie Inception, you plant a memory in somebody's head and you want to see how this changes, say, inflation expectations of people. In our particular context, we ask people to play a forecasting game. When you present people with actual inflation in 1971, they make a forecast. If there is an error, we tell them, well, there's an error this much. Now make a forecast for next year. They make a forecast and we tell them this was inflation in 1972. And so you train people on these past experiences from early 70s. Some people are going to play for 1960s. Some people are going to play in 2000s. And then because in the lab you have much more control and kind of dedication from these people, you can learn things which you will not be able to tease out from surveys. So there is a lot of potential in merging these two approaches. Question over there.
Thank you, and thank you for a very interesting presentation. You mentioned earlier that you see that in the time when people started to know more about inflation because there was high inflation, you saw that the effects of the treatments were also, they changed. I was wondering if you have any insights on what that means for also misinformation, because, as inflation started increasing, you also have a lot of, people go on YouTube and they have all these people talking in videos about how to deal with it and so on and so forth. So do they make them more resilient to the real information, or, if you have any insights on this?
Thank you. I think the winners of the prize this year would be much better positioned to answer this question. But I will say this, when you do randomized control trials, you have to go through internal review board that is going to look at your experiment and check if you're going to hurt those people in any shape and form, right? Ideally, they don't want to have any pain from this experiment. And number one flag in kind of stopping these RCTs from happening is you give people fake information, you give them something which is not correct. We have not done this, in part because we want to keep this area open for everybody else. If we do this once, then IRBs are going to be very aggressive on everybody else in this room. So speaking of general equilibrium effects. But having said this, there is certainly some scope when you can play with different bits of information. When you tell people truth, it doesn't mean you have to tell them all the truth, right? You can tell them a factually correct statement, but you can focus on different elements of this. And in our context, one thing we did was to inform people about different forecasts from the Federal Reserve Board. Right? You can have like high trajectory scenario, low trajectory scenario, middle of the road trajectory. And you can see on the margin how variation and what you tell people is going to affect their behavior. Having said this, again, I agree this would be a wonderful exercise, very informative. Maybe we will do this in the US on the grand scale if they kind of make up numbers about inflation, but hopefully not.
Okay, I think before Ellen, you want to say something? Yeah.
No, actually, I wanted you to elaborate a little bit more on how your effects can or maybe are not heterogeneous. So you have households, but you also have some results on firms, I expect, or in some of your work. So all these relationships in terms of the attention given, in terms of the intensity of a revision. So how does that translate into the firms, the price setters? And the second issue is, so you seem, you show quite big effects. I mean, in some cases, so information seems to matter. And yet it seems like our central bankers are usually find it extremely hard to communicate indeed. And so you don't seem to do anything extraordinary when you communicate. So it's just that you get their attention. So how do you, what kind of advice can you then give to our central bankers who are really struggling to even communicate their inflation target, right? So.
Yes, terrific questions. It's true when we get our PhDs in economics, we don't have any classes in public communication, PR, or anything like this. And obviously, people who make it to the top, they are not always very well trained to communicate with the general public. Now, how do we reach to the people? We pay them to participate in the surveys. So we pay to get their attention, and we use this window of opportunity to change their beliefs and do an RCT with them. But what I wanted to say, I guess, more generally is that what we find suggests to us that policy communication has enormous potential that has been very much underutilized. And in part, it's because central banks and other policy institutions tend to be very conservative. They don't want to talk to the general public, right? So they issue statements which are very dry, fact-based. They are not really communicating with the general public. You can change this. Think about General Motors. When they want to sell a product, they're going to have messages which are very specific to specific audiences. They'll have one commercial for old people, one commercial for young people, one commercial for people in Texas, another commercial in California. So you can have all sorts of things that are not typically done by policy institutions, and I see a lot of potential there. Now, firms versus households. This goes back to an earlier question. Obviously we have people who are very informed about the state of the economy. They have very good forecasts. Typically we think that professional forecasters, financial markets, are people like that. We also hope that, as I said, captains of the industry are very informed about the state of the economy. But when you look at survey responses that they give, and we have a recent survey with our colleagues at ECB SAFE, I see Annalisa here, where we ask managers to report their inflation expectations. And by and large, what you see in the data for managers is very similar for households. In fact, when you ask managers, what is your main source of information when you form your inflation expectations, they say it's personal shopping experience. And I thought this is crazy. They should never use personal shopping experience to form macroeconomic expectations. But they look at the price of milk, price of gasoline, and this is what is shaping their inflation expectations. Astounding.
Okay, now I want to say a closing word before we thank Yuriy properly. And I'm going to use this opportunity to get your attention and affect your choices, I hope. If I asked you a month ago, what does Bordeaux bring to your mind? What do you expect? You might have said wine, But having come, you, like me, will have been impressed by the city and by this intellectual environment here for the environment for economists. But then what about wine? Well, Yuriy took the opportunity to publicize his book, fair enough. I'm going to take the opportunity to publicize the wine panel, the wine economics panel that will take place at 12:45 in the Salle Asselin. I've seen the slides, and I think they're very interesting. They will be very good. And by the way, it's not due to me, but there will, I believe, be wine and cheese at the end of the afternoon available to everybody. So this would be a kind of warm-up, an intellectual warm-up to the closing of the Congress. So now I can turn to Yuriy and thank him enormously for opening our eyes to a number of things, and it was a really very stimulating Schumpeter lecture, and we're very grateful. Thank you so much.
Thank you.
So you got half an hour before you come to the wine panel.
Yes. The theory session and then the empirical.
What the hell.
Thank you.
Anyway, no, it was great. Really, really.
Congratulations. Thanks so much.
Yes.